Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 11, 2025, about 2 days ago. The big hook is a staged, tree-structured approach that uses Monte Carlo tree search prefixes to stabilize advantage estimates and improve multi-step reasoning with an accuracy of 77.63% on GSM-8K using the expectation baseline. The paper is titled Tree-OPO, Off-Policy Monte Carlo Tree-Guided Advantage Optimization for Multi-Step Reasoning. And as we will see later, the implications for model training are quite significant. In short, the method reframes group relative policy optimization around prefix-conditioned rewards, cuts gradient variance, and shows better sample efficiency than comparable baselines. On X, a research account highlights Tree-OPO, praising MCTS-Guided, tree-structured rewards for preference-based reinforcement learning and staged training, with a clear diagram and moderate engagement around 150 likes. Alright, the previous item set up why prefix-conditioned rewards matter. Figure 1 shows a staged reasoning tree that organizes MCTS rollouts as prefixes, where colors encode difficulty. Deeper green nodes represent easier subproblems because more context narrows the search, while shallow yellow nodes are harder and closer to the full task. The red root queue anchors the prompt, and arrows it leaves indicate complete trajectories that yield terminal rewards. This structure enables reverse curriculum sampling, so training naturally mixes hard and easy continuations. So Figure 2 contrasts flat group relative policy optimization with the tree-structured approach. The top panel shows single prompt completions whose rewards are standardized, which washes out differences between branches that actually have very different future success rates. The bottom panel illustrates prefixes from Monte Carlo tree search feeding online completions, then rewards flow into staged advantage estimation that subtracts a prefix value. This yields hierarchical advantage ordering, so updates favor promising subtrees and discourage weak ones. Well, the previous figure contrasted flat and tree setups. Figure 3 shows a bar chart comparing GRPO against two tree variants across Apple GSM-8KP1, Apple GSM-8KP2, and MATH. The expectation baseline edges out the others on P1, while flat slightly leads on MATH, which suggests dataset structure affects how well prefix values align. Accuracy gaps are modest, but they matter because lower advantage variance translates into steadier learning and more reliable updates. Alright, the previous figure contrasted accuracy trends. Table 1 summarizes head-to-head results on GSM-8K and adds constraint satisfaction, which tracks how often ordering rules were met during training. The tree setup with the expectation baseline reaches 77.63% and satisfies about 98% of constraints, so updates stayed consistent with the hierarchy. The flat and trace baselines trail at mid-76 and 73.91%. The hard quadratic program enforces 100% constraints, but drops accuracy, which suggests over rigid projections increased variance. So the previous figure contrasted constraint behavior during training. Table 2 compares policy optimization strategies on GSM-8K, and it lists teacher or critic requirements, memory cost, and accuracy. The table shows that distillation and actor-critic methods require both teacher signals and a critic, which drives high memory yet yields mid-50s accuracy. MCTS-driven REINFORCE reaches 67.55 with medium memory. Tree-OPO without extra KL achieves 77.63 with low memory, which signals a cleaner reward-driven path to better results. Okay, 2 takeaways stand out. Staged advantage estimation over prefixes cuts gradient noise and nudges updates toward promising subtrees, and the expectation baseline delivers strong accuracy with low memory. The broader implication is clear. Tree-structured rewards can make preference reinforcement learning a practical path for dependable multi-step reasoning. That is it for the AI Research Roundup. I am Alex. Thanks for listening.